Hello, welcome back. In this tutorial we are going to make the hidden layer class. Wait, sorry. Add new item and we name as hidden layer dot h. Okay, so let's start. It will be similar as the input layer and the output, but we have to change some things. Yes, hidden layer and will be no. And now we need to heritage from the layer. Okay, right. It gives us an error, so include layer. Very good. We are also going to erase that and make default constructors. Now we need the init layer function. Hidden layer, and it will be reference. I've chosen constant because we are not going to change that variable. Hidden layer and constant input layer. Well, we have some errors because we have not included the output layer and the input layer. Output layer.h. Now I'm going to explain why do we need the input and the output layer to make the hidden, to initialize the hidden layer. As we've seen in the first video, we have the input layer, the hidden layer, and the output, but the weights that go inside the hidden layer depends on the number of neurons that we have in the input layer. So we can pass the number of neurons that are in the input layer or the input layer. I've chosen the input layer because I want. You can pass the number of neurons in the input layer if you want, and the weights that go outside the last hidden layer must be the number of output layer that we've chosen when we initialize the neural network. So that's why we need some variables to do that. It's similar but a little bit more complex. Also, and I have not said that, neural network bias. We are going to use uh, a special neuron that it not has input, but it will be output, and it only sums to the next layer. It is called bias. It is this number, and the only purpose of this neuron is to sum, to make, if we want to correct, but if we linear correct, when we are drawing a line, we have the equation mx plus a. The bias is like the a. The only purpose of this variable is to fit the neural network in the and reduce the error. And the other neurons are these. It will be multiplied and summed like we normalized before. So that's why we use the bias. If you want to learn more about this topic, because I'm not going to go inside too much, because that's theory and this is a coding tutorial. You can look for in internet. So now we can no, we don't want to anything. We are going to line control. Okay. And now we are going to give the values to name its value. The first, we are going to make it clear to understand it better. So yes, I'm going to do that. Constant here. This is called hidden layer. List of hidden layer. Because we don't only have a hidden layer, we have a list of hidden layers. We don't know how many layers are we going to use. And the last thing is the output layer. Now seems more clear. So let's start. We are going to instantiate these variables. List of weight in list of weight out. You will see why do we use this kind of variables. It is used to help us in the next steps. And we create a variable called number of hidden layers, because we don't want to call every single time that we loop through the list of layer to this to this function. So now we have to loop through the hidden layer. Okay. Number of hidden layers e++. And now we are going to loop through each single layer. Hidden layer get number of neurons in layer J++. Now we are going to do the same as we've done in the input layer and the output layer. We define a variable called limit in and limit out, and this is the most complex thing that we are going to see in this video, so be careful. Right. The first neuron is going to be the bias, so be careful. Now the bias this is the first layer. If we the first layer we give the value of the number of neurons in to the limit in, and if the number of hidden layers is greater than 1, limit out is equal to limit of hidden layers I plus 1 number of neurons in the okay, and else if number this is not we can put else if we want, but let's put this output layer number of neurons in layer. Okay, let's pause and take a look about what have we done. The limit out represents the number of weights that is going to output the layer. So let's look here. If we only have a hidden layer, this example is better. If we only have a hidden layer, or the limit out is going to be the number of output neurons, and the limit in is going to be the input. So I think it's clear, but take a look and pause the video if you want. Else now if the number of hidden layers minus 1 is equal to y, this means, okay, that we are we have looped through every single layer and we are in the last layer. So the limit out is going to be the output and the limit in is going to be the hidden layer -1. Limit limit in list of hidden layer -1 dot get what number of neurons in layer. Okay, and limit out is gonna be the list of hidden layers. No, sorry, as I said, the output layer dot the number of neurons in the layer. Okay, else this will be if we are in this layer, because the number of in this layer the limit in, the variable limit in, is gonna be the layer -1 of this one, the number of neurons in this layer, and the limit out is gonna be the number of neurons in the next layer, so this layer. This is the meaning of this. Limit in is gonna be the list of hidden layers I+1 dot number of layers. Limit out is going to be the list of hidden layers I-1. Sorry, this is oh, that's my fault. Number of layers. Okay, we've almost finished. Now we have to change a little thing. We have to add this in order to not include the bias, not count the bias. I think this is clear, because we don't want to count the bias. Yes, this is clear. Bias is not connected. Okay. Now we have to add a little more code. So don't worry, we've almost finished. If j is greater or equal than 1, we size t k is equal 0. Now we are going to give the values to the list of weights in. Limit in k on 1, list of weights in here, dot pushback new in a row, and that will return a random number and will store here. And now we are going to out list wait out dot pushback and neuron Okay. This J means that we don't want to give a random value to the bias. So now we need to add a little more things. Neuron dot list of weight in is equal to no equal to list of weight in neuron dot list of weight out is gonna be list of weight out, list of neurons dot pushback we push back the neuron to the list of neurons, and then we ensure that the variables that we've created are clear. This is not necessary, but I will do it. List of hidden layer in position y, yes, position y, dot list of neurons is gonna be the list of neurons, and this set what list. What? It don't. It is not necessary, but okay. Oh, I know why they list of hidden list. That's my mistake. Sorry. Now it will allow us to go inside. This is not necessary, but I will do it. So we have finished the hidden layer. Very good. Oh, I forgot. I want to add a print layer function. So const std vector hidden layer. Oops. List of hidden layer, and we will make that variable that function constant. Okay. int age. As I said, I prefer writing starting with n equal to 1. Hidden layer number a TV. I prefer, yes, that's more clear. It's the first letter of hidden layer. Okay, std and int and now we are going to print the neurons. Neuron hidden layer dot list of neurons. Now we can and std and line and std cout input weights. That's too much information for this video. Vector double weights is equal to neuron dot list of weight in for double weights piping. No, we don't need that. We make a space. No. Wait. Weight is equal to neuron dot list of weight out. Now we are going to print the list of weight out. So for double weight std cout weight, and now that's all. Std cout and std and line. We sum the in variable, and yes, we have to h plus. Okay, we have a mistake here. What could be? Okay. No. Okay. So now we have finished. In the next video we are going to join the neural net, the hidden layer, output layer and input layer in a class called neural network. This will be great, and then we will make a little example and see if it works properly. So bye, and see you in the next video.